for a quiz last time. I think that was number 19, right? I think I remember it's 19. So last time we saw how to factor things, and let me do exercise number 19 just to refresh and also see how the quiz exercise is gonna be done. So if you factor x squared with x and x, and then everything is positive, then we put pluses. And looks like 16 is what I have to factor. There are various ways to do this, but in order to get 17 in the middle, I just need to use 16 and 1, right? And that's what pretty much everyone noticed. And the reason I use 16 and 1 is here you FOIL and you get inside product, which is 16x, and the product on the outside, which is 1x or just x. So together you put them and you get 17x. So that's the factoring. And that's it. You stop here. You don't make it equal to 0 because this is not equation. And that's very important to realize, that problems that appear on this side are completely different with problems that appear on that side. Because here we don't have equal sign. So those are not equations. So you just factor and then you stop. In fact, that's what it says here in the directions. Factor trinomial. So all you do is just factor, because there is nothing else you can do. For the next group of exercises, they say solve equation. So that's completely different. So yes, you're also going to factor, and that factoring will help you to solve the equation. Let me try to do one exercise here just to compare, like say problem number 39, that I will also start out by factoring, but then I will use this factoring to solve equation, which is different. That's extra step. So I just factored first term x squared with x and x, that's favorite start. Then I need to factor the last term negative 15 with one negative and the other positive. So it looks like it'll be negative 5 multiplied by positive 3. So you get this negative 2x in the middle this way, right? Because when you multiply these two, you get minus 5x. Multiply the other two on the outside, you get plus 3x. And minus 5 and 3 will indeed give you that minus 2x. So I did the same thing, I factored. But notice there is a little extra associated to this equation. It has is 0 on the other side. Here we don't have any zeros. So since my equation is set equal to 0, then what I need to do is solve it. And that's exactly what the question of related to this whole exercise set says. Solve your equation. So each factor that I have here, I need to set equal to 0. Why is that? Well, because when I have, let's say, x minus 5 multiplied by something, and the result is 0, then this something must be 0. See? That's the only way to get 0. You have to multiply by 0. And that's what I'm using here. So I say that instead of x plus 3, I could have 0, or I could have 0 here instead of x minus 5. So one of these must be 0, so the multiplication result will give me a 0. See, that's the whole point of this story. We have 0 on one side, and then we utilize it to solve equation. That's worth to think about. Because you cannot all of a sudden say, okay, let's make this equal to 0. Why? Why not 5? Why not 1,000? Why 0? There's no 0 here, right? So doing this is not going to be correct. Well, I didn't really subtract any points if you did it, but I should. That's actually the point. But it's okay. As long as we all can see what is going on, we learn, and that's the whole idea. So now I found two solutions. One of them is 5, the other is negative 3. And what those solutions mean? Well, if you use them here instead of x, if you plug them in, so you can always check your solution. So you take your original equation, x squared, so put instead of x5 minus 2x minus 2 times 5, right? And minus 15, and that will make it equal to 0. So the solution will check. 25 minus 10 minus 15 is indeed 0. So to find solution means to find that special number that makes your equation as a true statement, as a correct. So you plug it in and you see that indeed you got 0. And the same thing you can do with minus 3. We generally don't do that. We don't check our answers. They just say solve equation. And that's what they ask here. They don't say check. But they could be checked. And here there is nothing to check. You just factored and that's it. So you don't know what x is. You just factoring. Okay, so we did some factorings and I hope you enjoyed it. And on the next page, we factored more and we actually encountered those exercises that you couldn't solve by factoring. That was group that mentioned use of quadratic formula. So that was another group of exercises that we had here. And quadratic formula is something that you every once in a while encounter and have to use. So I guess I'll do a problem related to this story and see how we can use quadratic formula. Let's say exercise number 67, which is x squared minus x minus 14 is equal to 0. So we always produce 0. And it's not hard. You just bring everything to one side of the equation. So in exercise 67, looks like I cannot factor because if I try, the only way to factor 14 will be 2 and 7. Of course, there is 1 and 14, but it's not going to give you negative x in the middle if you try. So I must approach it from different perspective. I must use that so-called quadratic formula that we also saw last time. So let me refresh your memories on this. So if we have this quadratic equation in general, so 1 will be multiplied by x squared, so that's my so-called a. Negative 1 will be multiplied by x, so b will be negative 1, right? And c is the last number, which is negative 14. Please notice that we are adding c, so we actually added negative 14. So then the answer will be produced by using this so-called quadratic formula for solutions of quadratic equations. And this formula actually does not pop out of nowhere. We actually show how it works in algebra classes. So if you'd be interested, you could always look at it. But in this class, we just use Rayleigh formulas. So b has to be with a minus sign. So you have to put minus b. So I put minus minus 1, which is plus 1. Then I go with a plus and a minus. And this be square of b, so square of that minus 1. Subtract 4 times a times c, 4 times 1 times negative 14, right? So this is our so-called discriminant divided by 2 times a. So this is our answer. I just need to simplify this a little bit. And I put number 1 here, plus minus. Now notice that what we extracting the square root from is not going to be very nice expression. So it's 1 here. And then we multiply in 2 negatives, such as a minus 4 by negative 14. So it'll be 56. 4 times 14. So when I add 1 with number 56, I get 57. And this is divided by 2. So 2 answers, one with 1 plus, the other with 1 minus. But even if you write them separately, it's not really gonna help much. So you could leave the answer in this form. In fact, let me actually show you what they are. I think that'd be helpful. So there'll be 2 answers. One of them will be 1 plus square root 57 divided by 2. And the other will be 1 minus square root 57. divided by 2. So you could plug these in the calculator and see what the actual numbers are. So let me go to the calculator. It's here. So I can put them in, but I need parentheses. So I go to 1 minus square root 57. Right. And then I put parentheses, make sure it's divided by 2. So you have your answer that definitely doesn't look very nice. So 1 minus, that was the second, that was negative 3 and something, 0.27, dot, dot. See, those answers are some decimals. And analogously, I could find the other. I could just switch instead of minus, I put plus here. And here's the other one. This is going to be 4.27, dot, dot. So if you need to solve equation that you cannot factor, well, use a calculator. So you get those answers, and whatever they are, sometimes for word problem exercises, you need it. So the point is that you have those answers. But I don't try them with this 4.27. I just leave them as plus minus the square root. It's okay. All right, so I guess we finally finished with that chapter, with chapter 6. Chapter 6 is done, and looks like we'll move to chapter 7. How about that? More algebra. And in chapter 7, let me clean this. We got more exercises of the type that we already worked out, and I hope enjoyed. Those were exercises related to stuff that you see in algebra classes. So it looks like in the next sections, they start to talk about points that you plot on the plane of coordinates, on coordinate plane, and then they're gonna graph various functions. Let's see where it leads to. So we know how to plot points. Let's say favorite point is point of intersection of x and y axis called origin, point with coordinates 0 for x and 0 for y. Point here, 5 on x-axis will be with coordinates x equal to 5 and y is equal to 0. So it's good to realize that points that sit on axis have one of their coordinates equal to 0. For example, this point 4 on y-axis will have y coordinate equal to 0, y coordinate equal to 4, and x equal to 0. So either x is 0 or y coordinate is 0 if point is on x or y axis. That's good to realize. And otherwise, we have various points. So any point could be treated as a pair of coordinates x, y. So x comes first, x will be -5, and y will be -3. So you simply draw this perpendicular to x-axis and get -5, right? And to the y-axis, you hit -3, so it will be y equal to -3. So points are so-called ordered pairs. Order is alphabetic. X is first, y is second. So then you use these points to graph various equations. And that's what they do here in example 2. They look at the equation y is equal to 4 minus x squared. And they select various values for x and then calculate y's. And that's what they did here in this little table. That takes a while to calculate, of course. But they did, for example, selected x equal to 0. And when they use 0 instead of x, they plug this in y is equal to 4 minus x squared equation. So if you put 0 here for x, then y will be 4. And that's exactly what they done here. So they went through the process of calculation and found point with coordinate 0, 4, which is 1 up here. its so-called vertex. It's good to realize that when you have x squared, then you deal with parabola, and parabola is always a U-shaped curve that looks like that, parabola, and that's exactly what we produced here. But that parabola opens down because x squared is with negative sign, because its graph has minus x squared. So if you have a graph, for example, of parabola y is equal to plus x squared, then the parabola will, people say, open upwards. Both ends of it will go up. It means they just keep going. These arrows mean they just keep going and going without a change of direction. But if it's a negative x squared, then parabola opens down. And they verified this by doing lots of work, calculating various, for various values of x, they calculated y. So they tried x equal to 1, 2, 3, minus 1, minus 2, minus 3. So it's a lot of calculations they went through just to get all these little points on the graph of parabola. And once they produced all these little points, then they connected them with the curve. So that's the idea. Well, it's tedious. It takes a while to produce those graphs, but that's what they did. And I guess that's very impressive. So here they also graphed various lines, again, using points and other things. And well, I guess that's how people deal with those. So they graph those so-called functions by producing little tables and calculating little points. I think I'm going to do a couple of exercises here because I'm sure that you already saw how people graphing various functions. So let me do one of the exercises. Let's say exercise 33 here. Exercise number 33 has a function f of x is equal to x minus 4. And actually, this is a linear function. So in exercise 33, we're actually dealing with line. And I can see it from equation that they gave me. Equation is x minus 4. So instead of f of x, I can always use letter y. That's, I guess, convenient for calculating points. And since this is a line, and the reason it's a line because it has only x and y, no x squared, like here they have x squared, so that's a parabola. But if it's just x and y, then it's a line. And to graph line, all I need is a pair of points. So I don't want to overdo my exercise. I can use only 2 values for x. In fact, that's what they say. Use 8 and 1 for x. Okay, I'll use 8 and 1. It turns out it doesn't really matter what you use for x. And then you calculate y using this equation that they gave us. So instead of x, I'm going to put 8 and subtract 4 to get 4. So y is going to be 4 when 8 is used for x. You could use anything else for x. It is really up to you. But since they gave me that number, I'm going to use it. Analogously, I'm using 1 because that's what they told me in part B. Use 1 instead of x because function is actually f of x. So in the parentheses, we have x and x is 1. So I put 1 and I have another point here. So first one of my points is pair with coordinates 8, 4. So I can plot this on the coordinate plane. So somewhere here I put 8 and there I put 4, about a half of it. So it's right there, first point, pair 8 for x, 4 for y. And then second point with 1 and -3 coordinates, so someplace down below here, 1 and -3. So since this is a line, it's enough. We connect these 2 points and we'll get a graph. So it looks like problems with x in the first power are pretty straightforward to graph. You just calculate a couple of points. For the other ones, you will spend a little bit more time during the process. And well, you can try to graph another one if you feel like it just for fun. It's going to take a while though. In fact, that's what they recommend to do in problems like exercise 51. So they provide you with a table and they say, okay, use this function. So it'll be in the parentheses 0 minus 2. And the reason it's 0 minus 2, which is squared, is because now instead of x, they want you to use 0. And then you get minus 2 squared, which is 4, and you get yourself y. So this is x, and the other one is y. And so forth, so you could calculate various y coordinates. Like here, it's going to be 1, because when you subtract, you get -1, right? 1 minus 2, and then square, you get +1. Looks like the next one is going to be 0, because when I subtract 2 and 2, I get 0. When I square it, it's still 0, right? Etc. So with 3, I subtract 2. 3 minus 2 will be also 1. So when I square 1, I get 1. And finally, 4 minus 2 is going to be 2, right? And when I square it, it's going to be 2 squared, which is 4. So it looks like we have a bunch of points that we calculated. Let's see what they are. So first point is with coordinates 0 and 4, which means that y is 4, x is 0. Remember, this type of point belongs to the axis when its y coordinate equal to 4, because it's a pair x, y, right? So y is equal to 4. So we put 4 someplace on y-axis. And x is 0, so it sits on the axis, etc. So we have more points here. Second point with coordinates 1 and 1. So it's someplace down below. Like that, right? Next point is with coordinates 2 and 0. Look at that. With coordinates 2 for x and 0 for y. So on x-axis, I put 2, and 0 for y means it sits on x-axis. And looks like the next point with coordinates 3 and 1, right? 3 for x, 1 for y. And finally, another point 4 and 4. Let me take this thing away, it's on the way. So yeah. Last point with coordinates 4 and 4, someplace up here. It looks like indeed we have parabola because this equation stands for, let me write it here, y is equal to x minus 2 squared. So we have x squared here because x is raised to the power of 2. And indeed, this looks like a parabola when I connect these together. So whenever we have x squared, we have that U-shaped curve called parabola. So I'm not really going to get into very details of this section, do every single exercise, because it's going to take a while. It's like just a refresher. I'm sure that you graphed things before, and you could do just problems on this little page. Yeah, and that should be good enough for everything. So we can move on to the next section. So it's just points that you calculate, and then you plot them on the plane of coordinates, and then you connect them with a parabola or other things. In fact, in the next section, they talk about lines. So probably this story of parabolas and everything should have been shown a little later, because section 7.2 deals with graphs of lines. And lines is what I just did in problem number 33 here. So equations of line that have only 2 points, and then we connect them. So let me clean all that. Clear all this, share this screen again. And now it's all nice and clean. And it says graph lines. Graph linear equation means graph line. Well, they want to use special points, so-called x and y intercepts. What does that mean? Well, if you have a graph of line, let's say it looks somehow like that, then points of its intersection with x-axis will be called x-intercept, not surprisingly, right? And point of intersection with y-axis will be called y-axis intercept. So to find those points, we use zeros. Remember, when point belongs to the axis, then one of its coordinates is equal to 0. So what I do is I prepare a little table and I try 0 for x, and then I'll try 0 for y. And that way I will get those special points of intersection. Just look at this. With my equation, x subtract y is equal to 3. What I need to do is utilize 0 for y, for x first, and then for y. So let me prepare this. So in this little equation, x minus y is equal to 3, I'm going to use 0 for x, right? So put 0 for x, and it turns into 0 minus y is equal to 3. So what about y? Well, if minus y is 3, then I can bring y to the other side. I get plus y, which is equal to negative 3. In other words, when I solve this for y, and you can solve it any way you like. You can use, for example, the fact that you can bring y to the other side and it turns the sign to the plus, and then 3 will become minus 3 on the other side. Or you can multiply by negative 1. The point of story, the answer is always the same. So the point we have here is 0, negative 3, which is the one here on y-axis. So I just found y-axis intercept, negative 3. And that's what they wanted, use intercepts. So now I get another point. So now I'm going to use in this equation the number 0, but instead of y. So what I'm going to write here is going to be x minus, instead of y, I'm going to put 0. So y, 0. And looks like we have x equals to 3, right? We have this second point, which is point of intersection with my x-axis now. Point 3 for x and 0 for y. Just like that. So I connect these 2 points and get the answer, get my line, right? And that's really all I need. So we asked to graph. So there you go. Here is a graph. So this section works with lines. So I hope that you saw this story before. And if they want to intercept, well, you always create a little table with 0 for x and 0 for y. Let me take a look at this exercise, number 41. They also say that this is a line, but they say it could be either horizontal or vertical. See, that's surprising. Why this equation presents a line? Because it seems to me that y is equal to 4 is going to be just a point up here on y-axis, because y equals to 4 is this point. Well, not so fast, because this point actually has 2 coordinates. It has x coordinate and it has y coordinate. And x coordinate is going to be 0 and y is equal to 4. So what you actually have here is a pair x equal to 0 and y equals to 4. And please notice that nobody told you here in this equation 41 that x is equal to 0. they just told us that y was equal to 4. So we should indeed get something different than the point that we just produced. And indeed, it's going to be a line. And to get a line, I need another point. So what kind of point can I use? So far, I already have 1 point, 0 for x and 4 for y. Well, I can use some other number for x. I usually like to use number 1 for x. Excuse me. So if I use 1 instead of x, my y, according to this equation, will be equal to 4. So the point we have here will be point with coordinates 1 for x and 4 for y. So that'd be another point on the same exact horizontal level. So when you connect these 2 points, you will get the line. You will get so-called horizontal line that is on the level of 4. And if you try some more possibilities in this, let's say if you try 5 instead of x, please notice that y is going to be equal to 4 again, because y really wants to be 4. So no matter what you try for x, your y is always going to be 4. So they're all on the same, these points are all on the same horizontal line. So looking at this equation, I can do problem 42 and say to myself, this is another horizontal line. Since y is equal to 2, then this line is going to be passing through point 2 on y-axis, and it's going to look like that. Another horizontal line. Y is 2, just like that. You see? So all equations with y equals to some number will be equations of horizontal lines. So let's say if I do problem number 43 that says y is equal to -2. Okay, so the line will be here, pass through point -2, and that'd be its graph. Y is -2. And it's good to realize whenever you have y is equal to some number, the graph of it will be graph of horizontal line. Well, there is one more thing I need to show you in this group of exercises, such as exercise like 46 that says x is equal to 4. And turns out that analogously to the previous story, the graph with x equals to some number will be also a graph, but of a vertical line. So x equals 4 will be a vertical line. And you can always verify it using the little table just like we did before. So if I try various values instead of y, because x is always 4, right? According to this little equation, x is always 4. So it doesn't really matter what y is. Let's say this point will be point with coordinates 4 for x and 0 for y. Or if you try instead of y number 5, then it'll be a 4 for x and 5 for y. So if I try 5 here for y, x is still 4. So notice these points will be all on the same vertical line. And no wonder this is vertical line. So equations of various vertical lines are also here. Let's say exercise 47, I could write as x is equal to -1, right? That's what I'm going to graph. X is equal. And to get it graphed, I just get another vertical line that's going to pass through -1 on my x-axis. Interesting group of exercises. X equals and y equals. So what else appears in this section? Well, there is so-called slope story. I don't know if you ever heard this word. It is very popular topic, calculating slopes of the line. Looks like this section has a lot of information about lines. And if you took algebra class, I think you should have had one before this particular class. Then they talk a lot about lines and their slopes. And I'm sure you're familiar with it. Sometimes it takes a while. Some people say, Alex, I took it 20 years ago, so I forgot everything. So if you forgot everything, that's fine. I'm going to refresh your memory on this. So here's the formula that's called slope formula. Slope formula. So there's so-called slope, and they always like to call it as letter M for some reason. And the slope is equal to this type of a fraction. For example, if I look at problem 9, where I have 2 points, x, y, what people do is they call them as first point, x1, y1, and then they also call the second point as x2, y2. Just to tell them apart, that's the first point, that's the second, x2, y2. And then they put their coordinates, points, coordinates into this fraction. So I'm going to be subtracting y coordinates. So I'm going to be subtracting 5 and 6, right? y2 is 5, x2 is 6, like that. And also subtract their x coordinates, 3 and 2. And see what comes out. So it looks like there'll be a fraction. -1 is in numerator, +1 is in denominator, so it's actually -1. So the slope of this line is -1. And that's it. See, so what does that all mean? Well, you can make a picture of this line and see what negative slope actually stands for. Let us do this. So they didn't ask us to do that, but we can always graph. It's fun. So first point is with coordinates 2 and 6. So someplace up here will be my first point, coordinates 2 for x, right, and 6 for y. Next point is with coordinates 3 and 5. So it's probably someplace a little bit lower. Someplace here. 3 for x and 5 for y. And then when you connect these 2 points, you're going to get a line through them. And this line has negative slope. So it turns out that we say that line falls. That's what they actually stated here. The line falls means when you go along the line from left to right, you actually go down, like downhill. So it's falling down. Line has negative slope, then it's falling line. Like that. Okay, so that's all it is. Let's try number 15. Let's try one more here. 15. I hope you recognize this story of lines. Do you? So let me find the slope of this line. And then I'll make a picture and see what type of line we have here. So once again, we have their x coordinates and y coordinates to subtract, right? So we're going to have to subtract. So y coordinates, those are second ones. So I'm going to be subtracting -2 and +3. Second coordinates, right? The y. And y2 is -2 and then +3, so I subtract. And for x coordinates, I'm going to subtract 5 and 5 and end up dividing -5 by 0. They say, Alex, this is undefined. This is no good. Undefined. So how would you know that? Well, try to put this in a calculator. If I divide here -5 by 0, the calculator says it's undefined because we never divide by 0, right? We don't want to do that because it's undefined. So let's see what kind of line we're working with here. I can also plot this line, actually plot points and make a graph of it. So 5 and -3. Oh, 5 and +3, someplace up here. That's my first point, right? 5 and 3. And analogously, I'm gonna get the second point, which is 5 and -2. 5, comma, -2. So these 2 points, when I connect them, will give me a line which is very similar to the lines that we produced in the previous group of exercises. It's going to be the one similar to what we did here on that side, right? X equal to 4 looks like on this line, I can even say what the equation is, x equals to 5. So this be a vertical line. You see, vertical line we have here. And the vertical line has undefined slope. Undefined slope. I think I'm going to overload you if I just put more and more information. So I think it'd be good if you just look at problems here on this part of the page that is opened in front of you right now. I think that'd be good enough for homework. So section 7.2 and 7.1, which is just giving you introduction into the story of graphing. Just plot points and connect them. That's all it is. So these things, I guess, is what we considered today. So I think it's enough material for today. And now I need to ask you to do one thing instead of quiz. I'm not going to give you a quiz today, but what they want you to do, the college, is to fill student evaluation form. I'm sure you're familiar with it already. So all you have to do is go to the Blackboard, right? If you go to the Blackboard, let me do that. You go MDC Blackboard. So once you get to the Blackboard, you're going to get this. Let me stop recording. Record it. So stop recording today.